Welcome to Appalachian Bonsai. Today we're going to be discussing freeze-thaw cycles and how they relate to your bonsai soil. As water changes phase from a liquid state to a solid state, it expands. During warm months, water will find its way into small cracks and fissures within a rock. During the wintertime, as it freezes and expands, that water will eventually open up that crack a little bit further and a little bit further until it calves off and you have multiple pieces of rock. This deterioration can cause problems in your bonsai soil, depending on what you're using. Let's take a look. To perform this test, I froze samples of each soil type. They were then allowed to thaw and cycled again. Freeze, thaw, freeze, thaw. I used dry ice to speed up the process. In my region of Appalachia, I consistently have 2 deep freezes during the winter time. I tested 6 cycles, which should show me what could happen in a 3-year period of time. When your soil components break down, they will start to compact. As the pores within the soil become smaller, drainage and aeration are inhibited. More water will be retained than the tree can use. With too much water and not enough oxygen, your roots will slowly rot and die. Drainage and aeration will be discussed in the next soil video. You'll likely notice that the more porous the rock is, the more likely it is to fracture after freezing and thawing. Here you can see Diatomaceous Earth and some of the fracturing already taking place after 4 cycles. I am testing the same organic and inorganic components that I used in the water retention video. Let's begin by looking at organic materials. The organic materials are fibrous, and they have the ability to flex and expand as they freeze, but they do become stretched past their limits and break down. Bacterial will also help in decomposition, but that will not be covered in this video. After each sample was frozen and thawed, it was rinsed to simulate the melting of snow or spring rains. It also ensured the samples were well hydrated before they were frozen again. On the left-hand side, you'll see the control sample. On the right-hand side is the freeze-thaw cycled sample. Let's compare the differences. As we saw in the water retention video, coconut coir can absorb an incredible amount of water. It has excellent flexibility, which helps it expand during freezing. It maintained its ability to stay loose and break apart just like the control. It ranks number 1 for organic materials. Pine bark, which is one of my personal favorites, does take a long time to break down. After these freeze-thaw cycles, it was a little spongy in texture, but it stayed coarse enough to drain. Pine bark compacted a little and lost some of its vibrant color. Because it didn't break down very much, it only compacted a little, and it still drained very well. Pine bark ranks number 2 on our list. Commercial peat moss, once it's fully saturated, does hold lots of moisture, but it still doesn't drain very well. However, it did perform better than compost, so it's going to be ranking higher on the list. Let's take a look. The color had changed to almost black, and it was a little mushy, but it still broke apart pretty much the same as the control. Commercial peat moss ranks number 3 on our list of organic materials. Compost started out draining pretty well, but as the freeze-thaw test continued, it lost that ability. Compost, by nature, is already partially decomposed. Compost can provide excellent nutrition to the tree, but it does break down. The control sample was sticky but relatively loose. The cycled was muddy, clumpy, and extra sticky, and it didn't drain very well. It ranks number 4 on our list. Now we're going to look at inorganic materials. Granite has a non-porous structure, which means it does not retain moisture well. But this does mean that water doesn't get into cracks and break apart during a freeze-thaw cycle. As you can see, water continually drains through without issue. Granite maintained its structure and draining capabilities throughout the freeze-thaw cycle test. There is no change in color and virtually no change in size. Because of this, granite ranks number 1 on our list of inorganic materials in freeze-thaw cycles. Sand, like granite, is non-porous and therefore has few spaces for water to seep in and break it down. It drained well throughout the entire test. Its compactness is due to its small particle size, but we'll get to that in a later video. Just like the control sample, it ended up having a very stable consistency. Sand comes in at number 2 on our list of inorganic materials. Perlite also performed very well. It continued to drain throughout the test and only compacted slightly. This is all because perlite does not absorb much water. There was only a slight change in the particle size, and very few fines. I believe it is those few fine particles that gives the cycled sample a little bit of a darker color. Perlite ranks number 3 on our list. The Stay-Lite Permatil brand of expanded shale that I used doesn't absorb much moisture, which means it performs very similar to the granite, sand, and perlite before it. That is to say, very well in a freeze-thaw cycle test. If you look close, you'll see some fine particles in the cycled sample due to fracturing. Because of this minor amount, expanded shale ranks number 4 on our list. Lava rock is where we get to see it start breaking down some. If you look at the water throughout these cycles, you'll see that it starts to become a little dirty. Though lava doesn't absorb much moisture, it's just enough for frozen water to expand and break it apart. All the same, it drained very well throughout the test. Let's take a look. There wasn't much fracturing going on, but it was still enough for this to come in at number 5 on our list. The performance of Vermiculite reminded me somewhat of coconut coir because of its ability to expand when frozen. It retained its ability to drain, but it did break down and compact a little. It was a little mushier and a little stickier than the control sample. This ranks at number 6 on our list of inorganic materials. This is where we're going to start to see the power of water in a freeze-thaw cycle. Turface absorbs moisture, and you can see the particles starting to break down in the water. As it broke down, it began to compact, but it did not become mushy. In fact, it continued to drain rather well throughout the test. You can see the difference in particle size from the control sample to the cycled sample. Its structure was still firm, and it drained well. Turface ranks number 7 on our list of inorganic materials. Diatomaceous earth is known for its absorbent properties, which also allows it to break down in a freeze-thaw cycle. It has a semi-coarse appearance on top, but it has compacted fine particles hidden underneath. It began to have drainage issues at the end of the cycles. Because of the extreme difference in particle size and its inability to drain after time, Diatomaceous earth ranks number 8 on our list. You'll soon notice a big difference in pumice. It was ranked 2nd in our list of water retention, but ranked 2nd to last in freeze-thaw cycles. Drainage is already impeded after only a few cycles. It hardly drained with the last one. Pumice has a visible size difference next to the control. It compacted and inhibited drainage, and you can see how muddy it became. It was sticky, it was mushy, and it performed poorly. Therefore, pumice ranks number 9 on our list of inorganic materials. Akadama is number 1 on our list of water retention and number 1 to break down. The water becomes murky with every cycle, and visibly broken down after 4. It still maintained some ability to drain, but was absolutely destroyed when we were done. The control sample still has a good core structure. The cycled sample is complete mush. It's gritty to the touch, but it's broken down completely. Its excellent water retention is also its downfall in freezing conditions. Because of this, Akadama ranks number 10 and last on our list of inorganic materials in freeze-thaw cycles. I'd love to give a big thanks and shout out to Prana 2000, Gustavo Torres, Nacho, Adorn Thy Headset, and my wife Julie for finding some mistakes in the water retention video. Their corrections are down in the description of that video. Leave a comment yourself and I'll respond back. If you haven't already, find us on Facebook and Instagram. Like and subscribe, because there's more to come. Thanks for watching.